All right, so first I want to start off with some context, because for any live coding talk where we're going to go straight down and build something, I like to first ask, why are we building it? And when was it valuable to you? Why did you decide to build it? So here's a little application that I wrote for a demo that I did at Ember.conf this year. And the demo is pretty simple. It's like I have this list of items that I can work on, and they're unassigned, obviously. And then when I push them to the right, they become assigned to Toran. So I can click this little blue thing, pushes them over. But what's interesting and what I'm going to show off today is that a lot of times in bigger JavaScript applications, you run into this interesting problem where instead of in the old days where you'd query the DOM and kind of update the data 3 or 4 times in the different places on your web app, and this time, or this day and age where we actually have a lot of single page app data binding stuff happening, you still have sort of the same problem, but instead of touching an individual HTML element, you're touching different parts of the application to update the JavaScript object, just so that it renders the same data. So what I'm going to try and show is an example of where this falls down in most applications today. This could be Ember, Angular, React. This example is that I click on a person's name or a to-do's name, and what I expect is that this little project drop down over here would be filled in with the same name. It's kind of like a master detail. Have you heard that pattern where I want to drill down and sort of see just a little bit more information about that item? Or in this case, basically the JavaScript object. So what I'm going to point out here is at least a little bit Ember specific, how the router gives you some information, but then you're sort of left to your own device to come up with a way to share a data structure across the entire application. The data structure in this case is just an array of to-do JavaScript objects. Really simple. And I want to share them because, again, once I make a change to a JavaScript object, I don't want to have to change it several times. I want the UI to be in sync, and I really want a single pointer to a single JavaScript array. That's the idea here. So what can I do? Well, over here in the console log, when I was changing, I kind of console logged out some information, though, on the Ember side. And that is that I actually have some information about the item that I clicked on. And if you were really snazzy, you probably saw that the URL all the way up here is actually changing as I navigate. So if I click the third item, the URL has changed to /todo3, but it is also printed out, hey, I have this ID from the URL. Do you want to do something with it? And ideally, I want to go get that single pointer. So let's figure out how to do that in the finished application. Then we'll work backwards and write this magical cache that we're using. So the first thing we're going to do is just kind of flip over to the finished application and show the deficiency that's there today. And right now, this is a little Ember specific, but when you go to a new URL, this method hook runs, this function. And right now I'm just console logging out the parameters. But ideally what I want to show is how this was useful to me. So we're going to create during this talk this store object, and I'm going to go get the store. And then what I'm going to do is actually return the store's find for a to-do. And then I'm going to pull out the params.todo_id. And how did I know it was params to-do ID? That's what I see right down here, because I was console logging the params. OK, so now, why is this valuable, and how are these two lines somehow magically synced up? If I jump over and look at the parent route, and I want to kind of show these similar time. But basically what I did in the parent route is I go get, with just basic AJAX, I go get all of the to-dos, right? All of the to-dos on the back end. And then what I do that's important here is I loop over this JSON response and I push every single one into this magical store. You can think of the store as nothing more than just an in-memory cache. When you leave this browser application and come back, the store will be empty. It doesn't persist with local storage or anything fancy. But the idea is really important here is that if I push these in, I'd like to be able to retrieve them and have them a single object. Now, how does this manifest in the finished application? I'll kind of switch back and show you the final version. So you can kind of already see it because I snuck that in. But if I have nothing and then I click on the last, I actually have a true JavaScript object return. But what's even better, and the most important part about this, is it's the same object. So when I change it one place, it's changed everywhere. So if you've worked on single-page apps in the past and you've had to touch the DOM every time, there's, again, no difference here except you would have to touch JavaScript objects every time, and that just becomes a mess. And really what I'm trying to prevent over time is a maintenance nightmare in your JavaScript app. So this store or cache concept is what we're going to actually build. We're going to build it from scratch, test first. So here's the concept. Now let's go build it. I'm going to be using an Ember add-on, and the nice thing about Ember add-ons is they just give you a kind of boilerplate stack of build tooling, so you don't have to write your own testing tooling and plug in a runner and do your own build steps for uglifying it, stuff like that. It's called Ember CLI if you want to check that out. We're not going to talk too much about Ember CLI, but I can run a test with Ember CLI in this magical kind of watch mode. If you've ever done test-driven development or seen people do testing where they turn on like a watcher, that every time you change a test file or a production file, it reruns the test. That's what I'm going to do in the right pane, and then we're going to just use that test to get feedback. So one of my early sales pitches for anybody who came in late is that I'm trying to also demystify test-driven development as a silver bullet and more or less change it to be that test-driven development is about feedback. So I'm going to show that I use the test to get feedback this entire time. I will not go to a browser once. And when we're all done, we'll kind of plug in, and you already kind of saw the final product, but we'll touch on it one more time. So I don't have any failing tests, so that's kind of boring. So let's create a new file, and I'll throw it in the test folder. We'll call it store test.js. Store test.js. And to get started, we're just going to use QUnit. I'm not religious about test frameworks. If you like Mocha or something and you want to hurt me afterwards, that's fine. But the nice thing about QUnit, it just comes out of the box with Ember CLI, so I don't have to do any magical configuration here. To get started with QUnit, we're just going to import test and module from QUnit. In the module itself, you can kind of namespace, so it gives you some context when you see a test failure in the browser or in the terminal. And I'm just going to call this the store unit test because we don't need a lot of context right now. And the first test we're going to write is kind of the simplest scenario, which is, can I put something into this cache and then retrieve it by a unique key? The simplest thing known to man. So I'll just say push will add model to the store. Sorry, I'm switching from double ticks to single ticks because I switched from a Java team to a Python team. Very difficult to make this switch professionally. No, I'm just kidding. OK, so we're going to do a function here, and in QUnit, you get assert as part of that function. All right. So this first thing we're going to do, and again, what I said earlier is if you don't know a lot of Ember, fine, because a lot of this is very vanilla. In fact, so vanilla that when I start, I'm just going to new it up. I'm literally just going to say store is new store. What I'm going to do inside here is just push in a very simple object with a key and a value. More or less, the trick that we have to start with is I have to have some unique primary key or ID value to identify the JavaScript object, just like you would in an application. So I'm going to start out with an ID of 1. In this example, I'm going to give it one other property like name, just so we can have something to play around with. Next, what I want to do is go retrieve. So kind of the other side of the coin is I'm going to create this person object, to go get it by doing get by ID and just passing in an ID of 1. And then just the normal assertion with QUnit to say person ID is 1, hopefully, and that the person's name is Toran. Now, I'm going to use the tests themselves to give me some feedback. And so over here on the bottom, the first thing you see is that, hey, store not defined. So I'm not using really an Ember-specific module. I'm using ES6 modules. And if you're just unfamiliar, it's basically just a way to include other code. So at the top here, what this is kind of complaining about is I need to go import store, but from where? I haven't created a store. There is no production code. So let's just assume we're going to create it in this namespace JS, and we'll call it store, because that'll be the file name. So if we go create that before we save that file, I'm just going to put it in this add-on folder here. And the add-on folder in Ember is just really a place to include things in your project that are more like library code. So you can make this add-on, and then if somebody wants to npm install it, it's just accessible in their Ember application. So kind of the missing add-on story for JavaScript. So what I'm going to do here is create store.js, this missing file that we were working on. I'm going to import Ember. This is not really anything special. If you know vanilla JavaScript, you could just create a IFI and then create kind of a constructor function, the normal JavaScript stuff. I'm just going to use Ember because it makes it a little easier here. And then I think Ember's in the title for this talk, so I get to use it once, I hope. All right, so what we're going to do is just create the store JavaScript object, and it's, again, just Ember object.extend, just kind of just like creating the prototype here. And then to export it out, I'm going to use ES6 and just say export out the store as the only thing in here. And now if I save all the files, my error message is going to change. Export default store. I'm always missing this from keyword. There we go. So if I save this, I get an update here. And of course, JS hint is telling me line 2, I'm missing a semicolon. Thank you. But the real error is actually over here on the right the next step in this evolution is like, hey, store.push, and it's complaining that something is undefined. So basically, there's no method push. And I'll skip the boring details of writing out this function here. We're also going to need one more function, and that is, of course, get by ID. So if I save that, our message changes on the right. And the big takeaway here is that person.id. Well, person is undefined, so it's complaining that I can't get an ID of undefined. So again, I'm kind of using the test as my feedback here rather than going to the browser, refreshing it, seeing the error. This is my feedback loop. OK, so we know why push is not working. Basically, we don't have any production code to make this work. So I'm going to create just a really basic constructor function. And at the core, an object map is nothing more than, or nothing different than just a dictionary or a hash in JavaScript. So all we're going to do is create that. So I'll say identity map starts out as a empty list or empty map. And inside the push, we're going to have this data or this JavaScript object. And all we're going to really do is say, hey, identity map, you have this unique ID value, and we're going to assign the key and the value, basically data being everything for that key. And of course, now that we have that relationship in this identity map, we can just return this .identity map for the ID in question. So this is the really simple relationship that lets us look up objects by an ID. That's it. I wish I could drop a mic, but that's just boring. So we'll move on. There's obviously a lot more to the talk here. The biggest thing I hope to show is just as we iterate over this, we're going to use the test not only as a way to get feedback, but also to get feedback later when we want to make bigger changes, sweeping changes. So the next big change here is a little Ember specific, but in Ember, one of the negative trade-offs is if you want an observable object, you have to actually do a getter and a setter. So if I want to get the name and make sure I can get it as it's updated, I have to do a getter. And of course, it complains over there and says, hey, this is a JavaScript object right now. It's not an Ember object. Well, that's a simple change. I can basically just create a record and say that's an Ember object create. And honestly, if you're new to Ember land, this is nothing more than saying, I have a primitive JavaScript object. I just want to be able to observe changes on it because the browser doesn't support that yet. So by doing this update and then changing this local variable, we should get a passing test. All right, so the next step is something that I've kind of studied a lot of these cache libraries, and just kind of a nice to have is when you create an object, it's really nice to be able to get that right back. So you have the pointer you just created, that JavaScript object, you want to get it in return. So the next test we're going to write is just simply that. We'll say push should return the created object, something fun like that. And then instead of looking for person separately like we were down here by saying get me by ID, I'm just going to actually say, hey, person, I expect that is going to be returned from the push method. And of course, that's going to blow up, which is totally expected here. And right now, we'll just kind of do something sloppy and call get by ID using data.id. So we're going to refactor this in just a minute because I kind of see something coming up here. And so now we have this returning, which is fine. What about updating? What if I have a JavaScript object in the store and I just like push over the top of it with the same key? What happens in that scenario? So I would expect that push will update any existing object, just so that we can continually use push. Like if we have a couple objects in the store, and then eventually we want to get a fresh copy of those with an AJAX call, it just kind of overlays, and if there's any changes, they just pop into the UI. You don't have a big like remove object and then add object, that kind of weird UI. So what we're going to do is we're going to push two objects in here, and I'll just call the first one first, something fun like that, and then I'll push a second one in here. I'll just call it last. And we're going to change only one thing, and that's going to be the name. So we'll change the name to updated here. And I should probably change this local variable. Whoops. And I'm going to do two assertions first, just to kind of give us a heads up that things are working. Now, right down here at the bottom, of course, when I'm all done, I expect that if I push last, it still is going to return that JavaScript pointer, and I should have updated. Now, the test passed, which is kind of weird for this workflow I talked about. I wanted to kind of show that because the real failure is when I move this assertion down. Because getting it right away, of course, it's Toran. But down here, I expect it's been updated. So both first and last have the same name. That's the whole point, the whole reason I'm writing this test. So I'm going to delete this line up here, and then I should get a failure. And basically it says, hey, you were expecting to get updated down here, but we're still first because I don't know anything about updating objects. How is that supposed to work? So what happens here is we're going to move some things around, and we're going to create the record first or try and look it up. And if we actually have a record in the store, we're going to use kind of a magical thing in Ember, but in vanilla JavaScript, you just roll over, set all the keys and the values manually. Ember makes this kind of nice, so I can say record.setProperties, and just pass in the entire JavaScript literal there. Else, we'll just do what we've always done, right? Just push this stuff in here. And at the very bottom, just to keep all the tests passing, we'll still return the record regardless. So now the only real trick, aside from moving some stuff around, is if we have a record right away, let's just set the properties on it. Gets our test passing. All right, so that's cool, but so far we've been using basically one type of object, and in a real cache, you're probably going to have a separate namespace that silos you not just by ID or primary key, but probably by a type or some string that represents a type in your system. So what we're going to do in this test is just say push will respect different model types, something like that. And we're going to change the signature. So this is going to be kind of a big change. We're going to change the signature where the first parameter now is a string of the type you expect to look up. And then the object literal follows. So we'll update this to be, in fact, we'll just kind of work, for starters, we'll just work with one of these. And I'll rename this to person, because what we're going to do in just a minute is have like a cat, or basically some other object other than person. So in this test, I'm going to start out just pushing this in. And the first thing I should see is probably an explosion because I've modified the parameters. I've actually put a string now instead of an object literal. And the actual failure that I'm getting on the right is Ember object create only accepts objects. Now, why is that happening? Well, the first parameter used to be an object, so it was fine. Now it's trying to cram a string in there, which is breaking it. So one of the tricks I want to show is that because we're running more than one test, it's going to get very noisy very fast. And I know what I'm about ready to do is break the API. That's what I just did. So I'm going to comment out just for a brief minute all the tests above and focus in very narrow on one spot until I get this updated. So the first thing to do to get this passing is, of course, update the type, because that's a new parameter here, as well as get by ID. And that's actually another mistake here I made, is I want to make sure I use both. I want to exercise both here. So let's just say stored.get by ID. And I'll pass in person as well as a string, and the number 1. And everything's passing. Because I kind of glossed over that, I want to show that I basically just modified, to start anyway, I just modified the type information, which was really the push and the get by ID methods. So there's no failing test, really. We can obviously go up top here in just a minute and fix those. But what I want to show is if I have another type. So what I'm doing here is trying to show that even though you wrote a test the first time and you kind of got it passing, the test itself doesn't have to be done. You don't have to be religious about, well, this test has one assertion and it's done. I'm actually incrementally evolving the test to a point where it makes sense or it adds value. And where it adds value in this situation is if I have person and, I'm going to do person and cat, just because that's easy to mess around with here. And I'm saying push a cat in here, and I'm going to give cat a different name because it's not going to fail if I don't. And I'm going to give cat a name of Wat, and I'm pretty sure the IDs, whoops. We'll just see if this actually fails yet. So what I'm going to do now is I'm going to push first, ask questions later. Sorry, couldn't help myself. So what I'm going to do is I'm going to go, after they're already pushed, I'm going to go get and then do the assertions, because we saw earlier the ordering of these assertions does matter. So in this situation, hey, it looks like the actual cat person may not have updated correctly because we don't know anything about siloing these by type right now. We're just smashing over top of it. In fact, the earlier test you saw shows that that does work. If they have the same primary key, we just overlay it, which is why we have the wrong name here. But if we want to support that, we can actually update the identity map to be a little bit more siloed based on the type. So I'm going to create a local variable called typed identity map. And all this is going to be is this.identity map for the type. If that isn't anything yet, we'll kind of default it to just an empty hash. Next, we'll say this.identity map for type equals the typed identity map. And then finally, we'll kind of quit using the global this.identity map and just use the typed identity map. So now we can actually shove in to the siloed by type the particular ID. And I'm going to copy this because get by ID will be affected just the same. So no longer can we just return this.identity map by ID. We have to return the typed identity map by ID. And now the tests are passing. So all we really did in this magical duplication here is just kind of find a way to silo the hash a second time. OK, so now what we need to do is let's go back to this previous test and just kind of update the API. So right now, we'll just say these are all people that are being pushed in here. And oh man, did I introduce a bug? If anybody saw it and kept your mouth quiet, thank you. No, you know where it is. I know where it is too. Sorry, I built this in. So the idea is that the bottom test was very focused on different types. It had nothing to do and it didn't want anything to do with the update logic. So what I've done is I've stumbled upon a bug that I thought I had on lockdown earlier. And the problem is that back here, there is a get-by-ID call, but you notice a missing parameter there. How easy is that to do in JavaScript? I know I'm not alone, but I'll claim to be alone for right now. Just, you know, everybody's in the zone here. So, of course, I forgot type. We'll add that back in here. And now we're back to a good build. And unfortunately, I don't have any other built-in bugs. I wish I did. We'll just do the boring switch here to get this back passing. Okay, so push this in here. All right, now we should have 11-ish. Okay, so everything's passing. I got all this updated. We found my magical bug in there. One of the things that changes is, yeah, it's great that we have different types. But as you saw in the production code, or at least what I know, is that the record is actually one type. It's not a person. It's not a cat. It's really just a observable vanilla JavaScript object that goes by the name Ember object at this time. What I'd really like in here is something instead like this. So I'm going to comment this out just to kind of show before and after. So I'd actually like to do something like person.create or cat.create. But I don't want to import person, cat, and I don't want to touch this file every time I add a new model object to my project. So I need to find another way to do this. So I'll comment that out also. Ideally, what I'd like is this dynamic way to look up the object and then just create whatever it is, a cat, a person, something new tomorrow, doesn't matter. So this store can remain kind of a hidden library you don't touch very often. So to get this factory, we do have to tap into a little of Ember's dependency injection magic. It has a container built in. So we'll say factory is this.container.lookup factory, which just allows you to look up registered types. And we're going to look up a model. That's the type, and then person. So that's the extent of it. What happens when you have an Ember object is it sort of has this reference or pointer to the dependency injection container, and at any time you can look up types. That's all we're going to do. So unfortunately, if I do this, we're going to get sort of an explosion, and that is, whoops, this.container.lookup factory. It doesn't know what this.container is. And that's because I've kind of taken us out of vanilla JavaScript land with this change, and I've sort of forced our hand because now I can't just say store is a new store. Because if I just say new store, where's the magical Ember container dependency injection stuff? It's not there at all. So what I'm going to do actually is comment out everything in here so far, and then we'll kind of drive this next change to say push will create a rich Java, or I say Ember model object. And we're going to get a lot simpler here where I could probably even simplify this a bit. And all I actually care about is that person in this particular test is an instance of person. And of course, for this test to even work, I've got to create the kind of capital P person, which you can think of nothing more as like the parent blueprint or prototype. So I do this in Ember by saying Ember object extend. So what I'm asking for here is that this thing be a person. And of course, well, now I'm using Ember in here. So I have to import Ember from Ember. But once I get past this Ember error, we're back to the magical lookup factory. So how do I do this dependency injection system by hand? It all begins, or all starts with the store not being vanilla. So how do I actually create this store this time around? Well, just like you saw in the test, I've got to have this container, and then the container knows it's nothing more than this store we're building, right? It's a key value dictionary. So if I look up a, what is it? I can say store:main, and I expect store:main will produce the actual new up. It'll kind of new up the store for me, but provide all the dependency injection stuff. Now, unfortunately, where does this magic container come from? So I'll say, hey, container is registry.container. Well, where does the registry come from? Okay, well, registry equals a new ember.registry. And that's the whole stack. So if you want to create it by hand, this is really dependency injection with Ember, the basic setup. Now, the problem is I only used this registry to register. So if I say .register, obviously, I got to have this store:main thing, and I got to register the store object. But more importantly, what you saw in the production code is I've got to have this model:person, and it has to be something registered to person the type. So I'll bring person the type here at the very top. And now you see the big difference is it's not as simple as when we started, but that's okay. We're kind of iterating here, and I'd rather have the lookup be dynamic. So now that I've got a registry and a person registered and a store being pulled from that, I actually have a passing build. But this isn't a passing test. Why is that? Well, a lot of times, I think Gary Bernhardt, if you know that name, he came up with this term called slime, which is sometimes what you're trying to test is a two-part step, or it's two steps to get it from red to green. And so I kind of cheated here, and I just slimed or hard-coded it to be model : person. To make it pass, I'm just going to change person for cat. And then in the end here, I expect that, of course, I can create dynamic rich models. So I'm going to register both person and cat here. I don't know why cat. I just picked it one day. OK, so we got cat. And now I should just get a legit failure that is just saying that, hey, you expected this to be a cat in the very last line. And unfortunately, cat is an instance of person, if I had a better assertion failure here. So what do I have to do over here is instead of hard coding person, I already have the type information. So I'll naively, I assume everyone passes a legit type here. There's never null, of course, so we can drop that in, right? So we'll go a little naive, but we get the test passing. The big change now I want to show is that when you are test driving something like this, you're always in this constant design, improve, cleanup process. And obviously, one of the things, if I brought all the tests back that we're going to feel a lot of pain on is none of them have the store set up like this test does. But before I just go bring the next test back and try and copy paste it 4 times, we already have a passing test. So what if I just cut this and create kind of a before each setup up here, just to kind of run beforehand. And then I can bring each test back one at a time if I really want to. And I'm also going to do an after each just as a kind of a teardown. And kills me, this bracket. OK. And what we're going to do in the after each is just between tests kind of kill everything. So I'll have the container, the registry, and the store all get torn down. All right, and the other thing is person and cat don't really need to be brought in the setup. They don't actually change. They're pretty static in nature, so we'll basically create those as a constant. And then here I'll just have store, registry, and container. And then kill the vars in here so we can reference them down below. And now store, the big thing you'll notice is the change. Store is going to be set up for free. So I don't actually have to do store as a new store. Now if I make that save, all the tests still pass. So now the big win here is, the big win if I would have actually done this right with Vim, is I could have just done this one shortcut. There we go. And then I'm just going to remove that top line each time, which is var store equals new store. So I'm just killing this line. And then hopefully all the tests pass. And they do. All right, so that's the basics. There's obviously a few other missing methods to get this store complete to show the final version that we talked about earlier. So let me steal this guy so we're not watching me type the entire thing here. We are going to have an array-based method, and this will be pretty simple. We'll just say find will return all models for a given type. And, oh no. You can imagine that I'm probably just going to do something really simple. We'll push 2 in. The big difference is they need to have a different primary key value if we're expecting to be able to pull out more than one, of course. So I'm going to create a really simple local variable called all, and I'm just going to say store.find, and I expect to find all the people. And the big assertion here is that I have a length of 2. So I should get a basic failure, and it's blowing up saying, hey, store.find. Find is not a method on there. It's undefined. So now if we flip back to the production code, I can add a find method here. And for right now, let's just slime this thing again, just return the array for a minute. And we'll say this.array just starts out as an empty result. And then for the moment, because we won't have a failing test, I can actually say this.array.push record. So I'm going to duplicate the data structure work. Just go with me here for a minute, and we'll kind of refactor that out. So for the short term, this test is passing. But again, we can iterate on the test to make it fail for the right reason. So what I'm hoping to show here is that, yeah, I've got people in there all day. But if I add a cat with an ID of 1, I certainly don't expect to pick him up. So I still expect to get 2. But I think you can already guess what's going to happen. We got 3. So that's, again, because we were just kind of setting up the basic, we're doing the simplest amount of work to make this test pass, and then we'll just add the next failing test. So, of course, the issue is that array is just global. There's no type information here. So what we're going to do instead as we push this is do a very similar pattern. We'll create a typed array, and it'll be this.array for a given type, or an empty array to start if we don't have one. Then we'll say this.array for type equals typed array. And then finally, getting rid of the primitive, we'll say typed array.push. and then copy this up to our friend, the find method, who actually does all the heavy lifting here, and just return typed array. And true is not defined, so I'm sure I screwed something up there. Oh, typed is not defined, sorry. So obviously, if I'm going to use the type here, I have to add it to the signature of the find method. I usually don't do that on purpose because the first time when I had return this.array, JS hint complains and says, hey, you have an unused variable. So anyway, little minutia there. So now we have an array that works, but pretty clearly if you're the maintainer of this library, you're just hacking on this for fun, you can see that you've got two different data structures maintaining the same reference. You've got an array and a hash. So let's assume for the moment there's no performance penalty in doing a for loop and then looking it up versus a direct lookup. So we want to get rid of identity maps. So now that we have a whole suite of tests, one of the nice things is we have this freedom to come in here and change everything. So the only real switcheroo is going to be down here on getById, is instead of looking up a direct ID, we're going to have to return typed array.filter, just kind of do a basic filter lookup, and then return the 0th item because there'll be one or it'll be null. And then inside this, we'll basically just say model.getID is the ID that you passed in. And we have a passing build. So that was just kind of showing, you have some confidence, obviously, to come through here and change and evolve the library or the code that you're working on. So one other thing, though, is I see a lot of repetition in here, especially this block over and over again, which is I'm just getting this typed array, setting it up, pushing into it, or returning from it. So instead, let's actually create just kind of in ES6, you can do kind of a private method just by declaring a function above what you export. So we'll just create something called typed array, and it'll be an anonymous function. Somebody's going to get mad and say I should name that, and you're right, I should. OK, so we're going to come back here, and the only difference is, since this is a method outside of scope, we'll have to take the type and the store itself. So, oops, just replace this with store. And then down here, yeah, I know. So what's happening over there is it's saying, hey, typed array is defined but never used. So we're going to use it. So now what we're going to do is return typed array, passing in type and this. We'll also modify. Again, we're just kind of reducing some complexity here over and over. So we'll do a array type as well as down here. We can just use the function passing in the type and the store. And the idea is to get the entire build passing with the entire function set in one window at size 30 font. That's the entire store right there. Pretty basic stuff. So we're not quite done. There's one last change that's required to use the API, and that is this getById that I started with. It was really handy to kind of have a separate name from find and getById, but most of these libraries, in fact, the one that we plugged in at the beginning, uses find and kind of overloads it. So you can provide an ID, or you can just say find all. We're going to do a similar pattern here, so I'm just going to say replace getById with find. And of course, if I make that change, it's going to fail. But real quickly, we can come into find and just say, I'll call it options, but you could call it ID. And we could say, hey, if the type of options is undefined, then we obviously don't have an ID, so we're going to return the array. Otherwise, let's just return this getById. So it's kind of we can underscore it and make it a, hey, please don't use this. It's a private API, but let's be honest, it's not that big a deal. So we'll update that. The build is passing. That's pretty stellar. But to wrap it all up, let's go take a look at the final example again. And that is, so I'm looking at this route. And I want to look at these. Basically, the parent route here is on the bottom. And all I'm doing is exactly what you saw me test drive. I'm pushing an object in. It's sort of represented by its primary key and then the other JavaScript object attributes that go with it. At the end of this array, I return all of the to-dos. And that's what we kind of render in the big parent view or the master view. But then later, when somebody wants to request the same JavaScript object, they can very easily get the reference by an ID, primary key value. That being this magical guy. And as well, you also notice this is kind of an Ember thing I'll just show off. But what I love about Ember is the URL that you're at looks the same right now, no matter how I navigated to it, and if I do a hard refresh or send it to somebody. So I still get the same results. I still get the same data-bound object. I get the same rendered HTML you would get. The URL tracks that state. So that's me. My name's Toran. Thanks for coming. Any questions?
Out of curiosity, you're going fast, and I appreciate that. It was really fun. Good talk. Why was you decided to eliminate the
It was just for the demo. Yeah, I'm not a performance person, so actually in the final, I have a identity map that I use, and it's an open source project called Ember CLI Simple Store. It actually still has those two structures.
So you had to keep both. You couldn't make a way to write it back in.
I'd love a pull request that would fix it, absolutely. I don't know an answer to it right now. I meant to bug Steph Penner, who is going to be here, because he's more of a performance guy, to get his take on how Ember data and some of these bigger libraries handle having one single data structure rather than like you saw earlier where I had two. Because I assume there's some kind of performance penalty if I have to loop over the entire enumeration, a ton of objects versus a single hash lookup, but I don't know the details in JavaScript to say, oh yeah, here's the performance numbers to prove it. Yep. Sweet. Nice direction back there, by the way. Loved it. Yeah.
Totally new to TDD. I mean, just read the Wikipedia article.
Okay.
But so the right-hand pane, was that Ember CLI?
Yeah, yep.
Split screen?
Yes, sir.
The tests are actually running?
Yep.
Okay.
Whoops.
So
Yeah.
If that's Ember CLI, is there a similar tool for vanilla.js to do?
Yeah. I think behind the scenes. Oh, left and right? Yeah.
Right there.
Yeah, Testum is the runner, and you could use either Testum or Karma. What you see on the right here is Testum. They both have their own issues. I've used both in the past. And then whatever JavaScript testing framework you want to use, which out of the box is QUnit here, but you could use Mocha or Jasmine, and then just kind of compile that set of tools together yourself and either use Phantom, like you see here, or I believe the nice thing, too, about Testum is if I bring up Chrome, and I'm not explicitly running Chrome, but you'll notice down here, it actually says, hey, I'm listening on localhost 7357. So if I just come out here and say localhost, 7357, it'll actually just pick this up and run it in Chrome as well. So one of the tips, if you do get into this and you're actually at a weird, very complex step where you have debugging, you need to step in and debug some of your code or some library code. The best part is if you open up the Chrome DevTools and you want to actually step into something, you could always drop in. So let's say in this find method, I got cap lock on here. So if you want to drop into this find method, I can actually put a debugger here, save this, it'll bounce, rerun the test, and then once I hit that, I'm actually stepped in at this point. I can ask, hey, what's the type, what's the options, and that's just really Testum letting you wire that up. But Karma has a similar setup. So, yep. Cool. All right. Well, if you have any other questions, just grab me afterwards, and thanks for coming out.